Welcome to Regulate Tech. This is our 5th episode of 2023 with me, Nicklas, Berild, Lundböad, and...
with me, Richard Allan.
So, we thought we would talk about something that almost nobody else is talking about these days. A subject arcane and certainly not in the news, which is artificial intelligence. Yes, seems to be a good time
Flavor
to
of
talk
the
about.
month.
Flavor of the month. Yeah. And one way to approach this that I think is probably helpful is to sort of just talk through where it comes from and what the distinctions are and how we ended up where we are today, and then start from there to talk a little bit about what are the challenges when it comes to regulating different kinds of technology.
Yeah.
Does that seem like a plan?
It does, because I think there is quite a lot of confusion. As I'm very involved in debates at the moment around the UK's online safety bill,
Right.
where we're trying to regulate. And a lot of that discussion is how do we make it future-proofed? How do we look forward? And of course, AI has come up in that. But I do think there's quite a lot of confusion still about where you draw lines between different forms of technology, and they all get sort of muddled up. So I think teasing that would be helpful. And Nicklas, I know you're the man on this.
Well, I'll say at the outset that these are my personal views only, so you're not confused with anything else. And I think, as we start out, I think it's helpful to think through the history of artificial intelligence and to sort of go back to the 1950s when Alan Turing started to think about what it would mean for a machine to think, and when a couple of people, John McCarthy, Marvin Minsky, and others, decided that they would solve the problem of human intelligence in a summer school.
Yes.
So they drafted a proposal to study the way that you could program a computer to solve typical problems that a human could solve. And in that way, they wanted to create artificial intelligence.
So that gave us the theoretical framework. And does that still hold? Does the structure that they designed hold today as a structure that, now that we have the computing power and the data, is one that can deliver the hope that they had for AI?
To a large degree, yes, because the foundational view that they had, the vision they had, is the same. But the way they thought they would reach their goal is very different from how we actually ended up with the kind of technology we have today. The people who started the early artificial intelligence project were quite convinced that they could solve this with logic. Right. You could represent human thinking with predicate logic, and as you did that, you would have these systems that encapsulated ways of thinking. And you've heard terms like expert system, for example, theorem prover, and there are plenty of early examples of what is sometimes called GoFi, good old-fashioned AI.
Yeah.
And GoFi was essentially it was a way to think about human thinking that was highly symbolic, highly mathematical, and to a large degree deterministic. And this was something that the founders of AI thought for a very long time would be the right way forward. So I met, for example, with John McCarthy in 2006. One of the founding fathers, and interviewed him, and I had a very interesting experience interviewing him, because I asked him if he wasn't disappointed 50 years on after the Dartmouth summer school, and he said, well, not really, because all of the development that a foundational technology encapsulates comes in the second 50 years. Yeah. And he was right. Yeah. If you look at what's happened, he was absolutely right. And my idea of writing an essay about the sort of disappointed professor, it went out the window. And he scolded me for it quite severely.
He wasn't disappointed.
He was not disappointed. He was quite convinced that the next 50 years would mean that you had lots of breakthroughs. And he was right. But the ways those breakthroughs came, that was fundamentally different.
I think I remember that I did my master's degree in IT late 1980s, 1990, and they had at Bristol Polytechnic at the time, they had a transputer centre. Transputers, right?
Transputers.
And transputers were, I think, the kind of expert system you were talking about. I remember the example was that they had steel going through a metal strip mill, and humans would sit there and look at the steel, and they could spot impurities and say, that's a bad batch, send it back. And they were trying to train computers to do the same thing, and the computers kept failing. And I think they were trying exactly that. It was that sort of logic, if A then B, then do C sort of logic that they thought they could replicate from the human looking at the steel, doing quality control, and get a transputer, a clever computer, do the same thing. So I remember at the time they were kind of exploring it, but it turned out to be a bit of a dead end. So that sort of expert system, logic-based thing has sort of had a sell-by date. It's expired. What have we moved on to then?
We moved on to, and I want to simplify hugely now. We moved on to what can sometimes be called probabilistic models, where you should try to predict what something is. And by doing that, you're not looking for an absolute logical formulation of human knowledge. You're trying to get an approximate prediction of what something is, what a picture is of, for example. Is this a picture of a cat? What the next word in a sentence is, what the most likely translation is. And this sort of predictive model then became the dominant one through technologies like deep learning, neural networks. There's tons of different technical terms that we can apply here. But it's important to remember that to some degree, an interesting mental model of what artificial intelligence does is that it predicts.
Yes.
Because I think this is something that we'll come back to when we talk about regulating technology overall and how you regulate different kinds of technologies. Because there's a specific set of challenges associated with regulating predictive technologies, I think.
Right. And is that what we do as humans? We predict.
This is both the trap, the allure, the fascination encapsulated in the concept of artificial intelligence. That there's a silent third term in the middle, artificial human intelligence. We think it's us. We think it does what we do. And to some degree, this is probably true. There's a new book out by a guy called Andy Clark that essentially says that the human mind is a great prediction machine.
Yeah.
And what it does is it predicts what the next sensory input will be. And then it error corrects. So your entire experience of identity and self and all those things is error correction. Which is sort of an interesting view, right? I'm simplifying Andy Clark's quite advanced model, and it's a great book that we can write in the show notes about. There's also another book called The Predictive Mind that goes through that same kind of idea that the human mind is predictive. So it may be a better approximation, but we should still keep in mind that the notion of artificial intelligence at its heart is an analogy, a metaphor.
Yeah.
It's not the same because a computer did not evolve. It's not biological. It's not embedded in an ecology. It's not something that is sort of dependent on a body. It doesn't live, does not die. So there's there's a whole set of things where intelligence, as we think about intelligence, human intelligence is not easily transferable to a computational machines, but we are very tempted to do the
we anthropomorphize in quite a large degree. So we've got machines, not humans, that are good at probabilistic prediction.
Yes.
And then the other thing that's come in that I understand, and I understand this is sort of why there's been a very strong, for example, French input into the development of artificial intelligence. There's a lot around linguistics, a field that the French, in particular, French academic world are very, very strong on. How does this linguistics bit then fit into the pattern? It's maths, but it's also this element of language that seems to be critical to what's happening now.
Understanding how language works is a core part of understanding how you predict language too. And so there are plenty of different linguistic and actually philosophical foundations for a lot of the stuff that's happening now. And one way which you can see this is that you're predicting tokens in some models, to simplify. And what that means is that you're not predicting words, but you're predicting sets of words, or even smaller sometimes, and you can sort of choose what that is. So you have to have a theory about language. And that theory of language is sometimes connected back to things that Wittgenstein wrote, or things that you find in French linguistics. I used to be a linguist, but now I'm not so sure. Sorry. So there's like a lot of things that trace back to the formal study of language there as well.
Yeah.
And that's why that's why a lot of the focus right now is on what's called large language models, and what they do is, and how they can take a very large data set, how you can train them, and then they can predict roughly what it is that what you expect when you ask a thing or when you make a query to the model. So it's a really interesting field, because it's turned out that the people who invested heavily in their philosophy studies were right all along, which is very comforting to me.
What did you study, Nicklas?
Philosophy, accidentally, Wittgenstein. But the interesting thing is that as we left the GoFi, the good old-fashioned AI, the logical formulation and formalization of human knowledge, and started to sort of look more at these predictive models, enormous breakthroughs were made. And one of the fascinating stories in all of this is that there were few people who dared oppose the orthodoxy that said that, it's logical formalization, it's nothing else, and that kept working on things like neural networks, etc. And they, through enormous adversity, turned out to be right. So it's one of those interesting stories in the history of science where just keep plugging away on something you deeply believe in and keep exploring it, and over time it may turn out that you're right.
And
so
are those some of the same people that we're now seeing in the media quite a lot, often described as godfathers or godparents of AI, who are now
Jeff
concerned about
Hintons of the world,
Yeah.
Joshua Bengio and others. Yes,
Yeah.
and I think that there's and Jan LeCun, who I
Yeah.
think you know as well. So there's plenty of people who sort of started to think about alternative ways of.
So they were unorthodox rebels in their time.
Yes, and quite in many ways. The traditionalists stopped funding and all of those classical infighting things you can imagine. So the story of artificial intelligence written as a sociological story will be quite interesting once people really sort of look into that as well. And but here we are today, and we have discovered something quite amazing, and that is that if you think about these models, if you think about artificial intelligence as predictive, you can do some pretty cool stuff.
Yeah.
And you end up with models that can give you fantastic imagery. You end up with models that can write essays. You end up with all different kinds of capabilities that we thought for a long time would remain within the human domain only. And I think that's why there's such an enormous amount, or that's one reason why there's such an enormous amount of focus in this particular space right now.
Yeah. And a lot of those sort of stunning new applications, the common thread seems to be one of creativity, by which I mean, if in the classic model of computing, what you get out of the computer, you can know by what you put in. You program the computer to do something.
Yes.
If it's a banking system, you hope that when you tell it to add
you
up
don't
numbers,
want it to be probabilistic.
you don't know, or creative, it always adds the numbers up the same way.
Yeah.
Computers classically did that. And obviously that then doesn't give you anything novel. So if a computer that's programmed that way creates an essay, the essay is entirely a creature, if you like, of the programmer, because the programmer said, here's what I want in my essay.
Yeah.
And I think what we're seeing now, and what's interesting, is the essay that comes out, or the image that comes out, you couldn't go back to the code and explain, and you couldn't credit the writer of the code with the creation of the essay, if I can put it that way. There's some magic has happened between the person who wrote the code that they run on the computer that creates the instance of the AI, and the output, the image or the written text. You can't just do a linear trace back from one to the other.
The causality has become much more complex and opaque.
Yeah.
And I think you're absolutely right. And so in one way of thinking about this, if you want to sort of put a finer point on it, is say that we're building a technology that we have to study to understand how it works.
Yeah.
Which is very different from how we used to build technology, where we used to sort of have a blueprint, say the technology will do this, we would build it, and then it would do what we said it would do in the blueprint, and we would go like, well, that's very good. That's sort of a rational technology. Now we build a technology where we say we train it, which is a really interesting term. So we train this technology, and then we check what it can do. It can do all kinds of interesting things. It can produce poems, limericks, it can produce essays, it can produce images, and we find out what it can do by using it, which of course means that you almost need to adopt sort of a biological approach, where you're sort of studying these things as you would study birds, or how you would study different kinds of ecologies, and figure out, okay, what does this actually really do? And how does it behave? How does it fail? How does it react to different kinds of prompts, etc.? So you study it empirically once you have designed it.
Ooh, so just on this definition point then, I'm curious, one application, self-driving cars.
Yes.
So self-driving cars, people will say, are sort of powered by AI-like technologies, but is it? If we want the car to only behave in a certain way, is the AI that powers self-driving cars similar to the AI that creates a limerick or whatever? Is it given the same power of creative thought? And it strikes me that the car, you want to be much more predictable than you do the limerick writer.
Yeah, no, I think that's Well, it's interesting because you want to be predictable within a special problem domain. I
Yeah.
think. And you absolutely do not want it to be a self-driving car. You want it to be a car that drives you where you want to go.
Yes, yeah.
But it drives itself in some sense, I suppose. So what you're doing there is that you're solving a problem by allowing the machine to, in different ways, predict situations that can occur and then act on those situations. And it's a slightly different case.
But you're
but
not
I
going to
think
pre-program all the situations because
No.
you can't.
you can.
So you're allowing it to use an analogous experience. It can say, I know what to do in this situation, therefore by analogy I should do.
Which leads
this
to a
and
really
that.
interesting question. There's in the original sort of history of computers, there is this woman, Ada Lovelace,
Yes.
who is sometimes referred to as the first programmer, and worked with Charles Babbage and others. And there is, in Turing's original paper, there is a series of objections to the idea that machines can think. And one of the objections that he specifically mentions is Ada Lovelace's objection. And her objection would be it can never do anything new.
Yeah.
And when you see these fantastic the photos, the images, when you read some of the texts that the AI models can produce, you go like, well, obviously it can do something new, but can it? Or is what it's doing still a variation on a theme? And that's a really interesting question, because if it's a variation on a theme, then sort of what you put in still matters for what comes out. And the question is, can we do anything else?
Yeah.
Is everything that we're doing, is creativity fundamentally variation on a theme? Or do we have some kind of magical component to our creativity that allows us to create something entirely new? Can we do things in a different way than a machine can? And all these questions have come to the fore now because creativity has been the focus of many of these new inventions and new applications and new models and new software.
I mean, one that strikes me immediately is around language, where language is constrained by the physical human form. We can only make a certain range of sounds, and different cultures around the world have organised different sets of sounds, but they're all constrained by the physical being of a human. Computers don't have those constraints, do they? At the moment, we're teaching them how to operate language in a similar way to a human, but I guess that's one area where, left to their own devices, computers could come up with something that serves the function of language, but is utterly unrecognizable and entirely novel. It could be something that a human could never use. They'll find different ways to express themselves.
And you see some commentary along those lines when you see how computers and these modern AI applications play games.
Yes.
Because some people who are masters at chess or Go or whatever kind of game it could be, sometimes you can hear them say that it plays in a way that's almost alien.
Yeah.
Because we as human beings, we have a particular way of solving these games, of playing these games, and we have accrued that way over years of experience, centuries of experience, and there's like a human way of playing chess. Whereas that's not necessarily the best way of playing chess. And this raises a really interesting question, because humans have been exploring this enormous fitness landscape of solutions to problems. And more than likely, most of our solutions are local maxima, but not global maxima.
Right.
So we have some kind of solution to a problem that we're very proud of, and we're staying there because we think that's a good solution and nobody has come up with anything better, and why bother? And what the machines now do is that they rove across this entire fitness landscape, and they can find either higher local maxima or even global maxima in the solution space.
Yeah.
And they can play chess in an entirely new way. They can do other things in an entirely new way. Now, the question there is, what does this mean for art? Can they do art in a different way? Is there a criteria for art that is akin to the criteria for chess? Can you say that this was a well-played game, you won? This was a well-painted painting, you won?
Yeah.
Or what's the criteria for art? Is that fundamentally human? So there's a series of things here that that force us to rethink how we solve problems and how we learn. And at the heart of this, and this I think is actually important for how we think about regulating the technology, is that this technology learns. It helps us learn, and it learns. And as it learns, it can then predict different things. And thinking about learning, the regulation of learning, quickly turns out to be a really interesting perspective. Not the only one, but an interesting perspective to apply when you talk about the regulation of this technology.
Wow. And that, I think, again, there's something I've been thinking about around this question of agency, because it does seem to be, and here's the scenario that I was thinking about the other day, that I could imagine a scenario within which an individual is interacting with an artificial intelligence, so a program running on a machine, remember that, and the person who interacts with it didn't intend the output to be produced, and the person who created it didn't intend for a certain kind of output to be produced, because the output that's produced is something that is illegal. And this is where the regulation absolutely, comes to the fore. And let's just take the various sort of examples, but one example would be terrorist propaganda, illegal in many countries.
Yeah.
So somebody queries the AI and says, tell me about ISIS or some terrorist group. And the person who programmed it has programmed this machine to scoop up all the information on the internet about terrorists. But the thing that the machine spits out would qualify as illegal propaganda for the terrorist group.
Yeah.
And now we need to deal with that. It's done something illegal. You can think of other instances. It could put out something which is an image that would be regarded as illegal. Child sex abuse material, for example. Again, nobody intended that to happen. The person didn't ask for it. The programmer didn't intend for it to happen, but it's done something illegal. So this agency question then seems to me quite fundamental, where to date, absent the sort of AI piece, we knew who was responsible. Somebody produces a terrorist propaganda. We say, who wrote this?
Yes.
And who distributed it? And how did that happen? And we go and we find them. And in criminal law, you have this concept of mens rea, which is criminal intent. You go and you look for the controlling mind, the person who intended the bad thing to happen. Yeah. In this case, as I say, we've got potentially an innocent person engaging with the AI, a person who can prove their innocence, an innocent person who's created the AI. It's the AI, the machine, that has done the act which is regarded as illegal. So where do we assign the intent in that, other than to the machine?
Yes.
And can you say that a machine has any kind of intent, criminal or otherwise, independently of the other parties it engages with?
Well, this is we run into a series of complicated problems here, and they have to do also with the way that we use our language and how we think about things like intent, because we have when we explain how something works, we have different stances, as the philosopher D.C. Dennett says. We have what is called the sort of physicalistic stance, which is I can explain something by explaining it as a series of quantum phenomena collapsing in a certain fashion. We have the mechanistic stance, which is I can explain something as a machine and say this cog doesn't really work. And then we have the intentional stance, which is I explain something as if it was done by an intentional subject with agency. And these different stances we apply in different ways. And typically when we talked about technical systems, we have applied mostly the mechanical stance.
Yeah.
It broke, it had a bug, those kinds of things. But as these systems become more complex, they start to exhibit an extreme competence. And when they do, we are lured into the intentional stance. We start to describe these systems as intentional. And we go like, well, it didn't want me to get the right answer, or it wanted to do terrorist propaganda. And we use terms as want, it intended. We start to apply intentional stances, intentional explanations for these systems, although they have no intention in themselves. And I think that's really interesting, because it creates another kind of problem that Dennett also pointed to, which is that we have evolved as human beings to believe that competence and comprehension are tightly coupled. When something is really good at something, we believe it understands what it does.
Yes.
But these
because in a human,
don't.
that would normally go together.
They will always go together.
Yeah.
That's how we evolve. So we don't have a lower threshold for understanding when something that looks intentional actually isn't.
Yes.
Or when something that looks competent doesn't comprehend anything. And so this will lead us into a series of traps where Dennett has pointed out, and I think he's quite right, that one of the greatest dangers, and where we should think perhaps even about regulation, is premature delegation to the machine, because we confuse its competence with comprehension. And whilst it's very good at doing something that might be a type case, when the exception comes in and a human being with comprehension would say, oh, it's an exception, we can sort it, the machine won't. and it will fail in unexpected ways because it lacks comprehension to complete its competence. And so I think there's something there. And going back to your question, then we can ask, is it really right to describe the system that produced this as intentional?
Yeah.
Can we say there's a locus of agency within the AI? And I think the answer to that question, if you look at all the systems we have today, is no. That's why if you look at anyone who works on these systems, they have a long testing period where they try to eliminate unwanted behaviors. They test these systems. There is a lot of human feedback that is used in order to try to eliminate certain kinds of responses. And you will see this if you use any modern chatbot. It will occasionally say, as a chatbot, I can't answer that question. And that is often a sign that somebody has been trying to fix the model, to take care of those kinds of dangerous behaviors, and then sort them out. And I think there's a really and that in itself suggests that the makers of these models feel a responsibility for them to make sure that they don't behave in unexpected ways. And I think that's probably where we are today. But you're also asking a bit of a science fiction-y question, which is there a point at which these systems can acquire so much agency as for it to make sense for us also to have some kind of legal accountability attached to them?
Yes.
And I think what we're going to have to do is that when these systems move from being tools, which they are today, mostly, I would say we don't have anything that has true agency, that wants something, right? We have tools. But when they move into being agents or have more agency, then at that point we need to start looking at what were they actually empowered to do by the person who used them. And we will then have to look at legal models that are more based on delegation. So for example, we have tons of legal ideas about how to think about delegated responsibility in our legal systems. One example is a parent and a child.
Yes.
So a parent has absolute responsibility for a child, except for some edge cases. And another example is the delegated ability to enter into contract in a company, where you delegate different kinds of powers. So you can imagine that one interesting piece of legislation in the future, or regulation in the future, will be saying that, okay, what kinds of power will these agents have, and how does it have to be delegated for the responsibility to go back up to the person that delegated it? Because if you go to a company, for example, you can delegate some things, but some things boil up to the top.
Yeah.
And for a parent, saying that, it's when your child breaks something, you can't say, never seen them before, if you might want to. And so there's like a whole system of delegation rules, delegation regulation, that I think becomes applicable the closer you become to the agent level. But I wonder if we'll go the full... There are some people who argue we should go the full, do the full thing and say, we should have legal personhood for these. And if they're not behaving, then, there's the option of erasing them, of doing something like that. But today, that's still it still seems like a distant solution.
Yeah. I mean, I'm as we're discussing this, I'm getting more and more nervous about the idea of anthropomorphizing what is a machine. It's code running on a machine.
Yes.
And the further we get away from that, the more problematic it is. And you say science fiction, we start thinking, do androids dream of electric sheep
exactly.
and Blade Runner replicants and all that sort of stuff, and you get into all kinds of trouble, I think, once you start treating a machine as in some ways a human.
Yeah. But there are people arguing for robots' rights, seriously thinking that that's a good idea. And the argument against, of course, is that there's an enormous devaluation of human rights to argue that robots should have rights equal to or even akin to those that humans have.
Yeah, and that does worry me because, again, some of at the moment we're talking about this because there's a lot of apocalyptic talk about machines running riot and things, and that strikes me as that's almost people assuming we're moving into a world where they don't operate the kill switch. Every machine, if you want to turn Chat GPT off, somebody at OpenAI could push a button and Chat GPT is turned off, literally. I mean, that's at the moment all those machines are living on computers powered by electricity, and if you pull the electricity out, that machine ceases to exist. And it worries me that some of the apocalyptic thinking is almost assuming that the machines will be running independently and no one can control them. And that again, that makes me uncomfortable. It should be a world in which machines are controlled by humans.
Yes, and I think there's a ton of research that goes into AI safety and AGI governance to figure out exactly how to make sure that that's the case.
Yeah.
And I think with today's models, you're right. Today's models are not necessarily the kinds of models that will run amok. There are nuances here that are getting lost in the apocalyptic sort of discourse. And I think one of the things that the more reasonable people are saying is, look, if these systems continue to evolve at the pace they're currently evolving, at some point we should expect them to be complex enough to perhaps copy themselves from one server to another.
Yeah.
And at that point, we might want to think about how they proliferate, just like we think about computer viruses, for example. And if they're also competent, very competent, without comprehension, they might do different kinds of things as they copy themselves from server to server, because they are in some sense misaligned. They have, we ask them to go buy something for us and they couldn't buy it, and now they're going to do everything they can to buy it, and so they disappear out on the internet and they wreak havoc in different ways. And so what was sort of the right way to approach the, as you say, apocalyptic discourse is to think about how we build systems today that allow us to retain control. And that is what is usually referred to as responsible or trustworthy AI in policy speak. But the intention is to ensure that we have a human-centric perspective here. And there's tons of interesting theories about how to do that and how to make sure that AIs don't assume that we want something and then turn us all into paper clips, like Nick Bostrom said.
Yeah.
And I remember I was recently in a meeting where Stuart Russell had this really interesting theory where he said one way we can do this is to make sure that as machines become more and more intelligent, we make them less sure what we want. So they become more attentive, more sort of like, is that true? Is that what you want? Sort of.
I think there's some interesting questions around the underlying infrastructure in there, because you describe it, in some ways, the original internet worms were code that was written to seek to replicate itself and do whatever it could to replicate itself. And we do need it may be
that... you slide into intentional language there? It did whatever it could to replicate.
Well, it was designed, it was programmed to replicate.
Yes.
That was its instruction. Off it went and followed the instruction it was given. There was no intention on its part. But again, you might end up with an infrastructure. So part of it is compartmentalizing as a part of the defense might be, I want to make sure that there is always a kill switch for every part of it, so that, I can isolate, just you would with a virus, actually. Yeah. I can isolate the virus and destroy the virus without destroying the entire body, which is the problem that we have. And so we want to, and that may lead to a different, a less open global computing environment in which you make sure you can compartmentalize.
For a subset of systems that are really powerful, that might be the right. It's like we have only you can think about this as what is sometimes called air gapping, that you develop these systems in an unconnected way. And you can sort of try to figure out how to do that. There's a lot of theories and ideas and a lot of really good research that goes into thinking about how you can safely develop very complex and capable systems. Yeah. And if we just back away a moment from the apocalyptic discourse and we ask ourselves, should we be concerned that we're developing more capable and complex systems, and think about how we can still govern complex and capable systems well? The answer is an obvious yes.
No.
Yeah.
Because
we want that.
The answer is no.
But if you sort of layer all of the AI discussion on top of this, then you end up with all of these sort of dystopian scenarios. But I do think there's a real sort of at the heart of this, a very sort of theoretical, we have a regulation perspective, right? From a regulatory perspective, if you build something that's highly complex, extraordinarily capable, there's probably an argument for thinking hard about how that particular system is regulated.
Absolutely. And I just want to take you back to something you said a little while ago on agency, which struck me as really interesting, which is this notion of a sort of corporate responsibility. And it brought to mind the thought, again, this will anthropomorphize it, but that's not my intention. But in a corporation, if you have an employee that does something bad, that there are well-established mechanisms for trying to understand whether the employee is a rogue employee and the employer shouldn't be held liable, or whether it was something that the employer should have predicted and or encouraged or is somehow complicit in. And we can look at that. We can look at the bad thing and we can try and assign responsibility. And it's contextual. It's case by case. It's not that you can say every time an employee does something wrong, it's always the employer's fault, nor would you say, every time they do something wrong, it's not the employer's fault. You have to go in and look at the specifics.
And now you can extend your analogy. You can say, okay, what about if this company has used a auditor for hire or somebody that was hired in from another company?
Yes.
Is that company then responsible if that person goes rogue? And that's how you can see across the value chain of the artificial intelligence system how different parts might have different kinds of responsibility for what happens in the system.
Yeah.
And so you can expand that analogy to think hard about what it means to sort of assign the locus of agency well.
We do need to assign, I mean, there is a difference, obviously, and again, we're thinking about this in the context of the online safety bill, that you can't send an AI to prison. No. Or fine it directly. You can fine its owner, but you can't fine it. So a lot of the tools that we use in law to hopefully dissuade people from bad behavior and or send a message to the rest of society, there is bad behavior, those tools are not available. But some of certainly the notion of assigning responsibility is there. But for your regulation, you're going to have to think what the punishments are. Yes. And the punishments, the schedule of punishments may be quite different. I think for an AI, typically it would be retraining. So it's not a human. We're not punishing the AI, but we are saying that the owner of the AI must carry out certain functions in order to be, from a regulatory point of view, entitled to keep that AI going. And I say in some instances that if the behavior is really bad and repeated and doesn't seem to be getting fixed, the regulatory solution is effectively a death sentence for the AI. That the person, the employer is going to be told you must turn it off. You just can't have it.
And I mean, and it goes back a little bit into sort of a discussion about we currently have an up and coming discussion in the European Union about product liability. And it goes a little bit back to sort of how any product works. There's an intended set of behaviors that a product has, and if it has a set of behaviors that are not intended, you have to look at them and see if they're harmful. And if those behaviors are harmful, you either hold somebody responsible or you prohibit those sets of behaviors. And if those set of behaviors still persist, then you have rules of liability.
Yeah.
And so I think this is something that we'll have to think hard about, because instead of we will be trying to understand the kinds of behaviors a system can give rise to, engage in, and then classify these behaviors in different ways. And what we'll say is that behavior is okay, that behavior is not so okay. And it will be really interesting to see how we do this, because traditionally we have now been very careful, actually. If you look at many of the models that are out there, they're quite careful, almost to the point of where some people say they're boring.
Yeah.
You can't get it to say anything exciting. And there's an argument for thinking through how you train a model like this so that it can exhibit some interesting but problematic behaviors. But a favorite example that I saw recently online that I thought was really interesting was, should a language model be able to simulate Adolf Hitler's argument for a greater Germany, so that kids in school can argue with and see the flaws in Hitler's reasoning or not?
Wow.
And that's such an interesting... I remember when I read the example, I was like, that's hard.
Yeah.
Right? Because you wouldn't like to have Hitler in your classrooms, obviously. But on the other side, imagine if we had a generation who grew up and saw the flaws and could see the weaknesses in those arguments.
As opposed to have to see Hitler won elections.
Yes.
That's what makes me nervous.
Yes,
there
you go. Yeah.
It wasn't he.
Here you go. And the example is provoking. And you can sort of, and you can say, we don't want that.
Yeah.
We don't want the models to be able to simulate, and then you have really interesting services like Characters AI that are simulating historical and fictional characters, and you can sort of instantiate any character and have a conversation with them. One of them is the guy in Tony Soprano.
Oh,
So
right.
you can have a
Yeah,
conversation with him. Is that problematic?
yeah.
For a fourth grader having a conversation
With a nice gangster.
with a nice gangster
Yeah.
teach you the rules. So these are the kinds of behaviors, the kinds of things that we will have to think through.
So let me dig into one aspect which has come up a lot in the debate, which is the misinformation piece. So as you say, the AIs are careful. So I could imagine a mainstream company will release something that can produce images and videos, but will be very careful to say, we're going to stop anyone doing deepfake videos for political purposes, and they'll program in a list of all the names of people that you couldn't possibly sort of impersonate, things like that. Could somebody else take the same technology who's not reputable, so your Russian bot farm or whatever, how easy is it for them to go, aha, I'm just going to copy that technology and create an instance of it without the guardrails, and I'm going to pump out the propaganda?
Then this is a hard question. And it's hard because it also touches on something that is not entirely easy to sort of sort through, and that is the open sourcing of models. So if you open source a model, anyone can download it, anyone can build on it, anyone can tweak or fine tune it in different ways. Then you can, of course, also build a model that's intended for misinformation or intended for some kind of other kind of purpose, and it can sort of pump out politically targeted misinformation in different ways. And there are many advantages of open sourcing as well, because it could be a great way to get things out and build new kinds of really good applications and draw on the sort of the innovation capability of the entire ecosystem. So there are arguments for and against here, to be clear, but the kinds of control that you have if you provide your service through an API or through sort of a service online, and the kinds of control you have of the open source are radically different. And in the latter case, you don't have any guarantees that it cannot be used in the way that you envision. So I think that's a debate that we haven't fully sort of engaged in, and we're sometimes lazily, I think, equating open source of AI models with open source of operating systems, where they're really kind of different. Because when you think about open sourcing an operating system, it was because you would have access to the code, you can build on it, you could sort of figure out how it works, all of those different things. You really can't do that in the same way with a model if it's open sourced. And sometimes we even talk about this as democratization of AI. And there are a lot of people who argue that we should democratize AI, we should release all of these models openly. But the counter argument that you hear from others is that democratization doesn't mean free access to. It means access that allows for deliberative decision making. And that's different.
Yeah.
And so so this is a live debate where people there's no consensus around this, and it's really hard. But I want to bring your misinformation question back to something else that I think is being missed in this debate. And as we focus a lot on the production of misinformation, and we focus a lot on the elimination of misinformation, we want to remove it. We spend far too little time thinking about how to create an authoritative source.
Yes.
And that's the thing that sort of is being neglected in the debate. How do we recreate authoritative sources online so you know that this is a more credible source than this? That's really hard, but it's something that we should spend much more time thinking about. And along those lines, most of the companies that are now thinking about how to stop deepfakes and how to make sure that you can understand that something was generated by an AI are looking into things like watermarking or provenance detection, things like that sort of reintroduce the notion of authority into what is a flat information space online. And I think that's something that if we can get that right, we can sort of not just focus on the production of misinformation, but the production of qualitative information, authoritative information, and figure out how we can get to a point where there are some recognized sources that are authoritative online. Our problem is not that there's so much bad information. Our problem is that the good information we have is not recognized as good information. So
yeah, I mean, it's making me think that we're focused on, if you like, the offensive use of AI, but less on the defensive use.
Yes,
put it that way. Which, because as you explain that, it makes me think that, look, TikTok's AI-driven algorithm should be able to do exactly what you're saying if they chose to, and distinguish authoritative from non-authoritative sources. So maybe it's not even, I mean, there are old technologies like watermarking and putting something into the source, or dare I say that it comes from a particular brand of news media. And we have struggled to do that, but there are other ways of doing it where your phone and or the service that you use uses AI driven technology to keep up with the AI produced content and filter it for you according to a set of rules, and question who sort of defines those rules. But if you want to take out all of the bad deep fakey type stuff, it seems to me that having that defensive tool in your device is going to be the best way to do that.
Yeah, I think so. And also figuring out ways in which we can ourselves impart authority on a source that we think is the right one. It's not a clean solution, because some people tend to polarize and say, I trust this, I trust that. But there should be a way. If you remember PGP, I'm dating myself, but PGP, you could sign each other's signatures. And somebody who had a signature was signed by a lot of people had a very credible signature, because a lot of people said this person is the person they say they are. So you could accrue credibility over time. And credibility systems is something that we should spend more time thinking about. How can you make sure that you accrue credibility over time? And credibility is not the same as a like. So you have to figure out a way in which you weight it. And so somebody who's more credible might have a greater weight in giving credibility to somebody else. And you can think a little bit about how you weight a system like this. But I think at one necessary thing, if we don't want the information space to descend into noise, is to figure out how we create networks of authority, of authoritative sources throughout the information space.
People get there. And there are people thinking about that. I know there are sort of content provenance measures. If I sound a little skeptical, it's just that it's sort of from a political point of view, it's understanding that people have to want the authoritative material, or either they have to actively choose it, or the platforms have to choose it for them.
This is a paternalistic problem. Right?
Yeah, and so you've got that challenge. I think there's a lot of issues around choices that individuals are making in the information space, and the assumptions that we sometimes make as policymakers and regulators about what they want, which may not accord with reality.
And this is hard, because at some point you have to figure out if you trust people to be citizens and give them the agency to decide what they believe is credible, and then draw on that credibility assignment and use that as your source, or if you want a more formal authoritative assessment. It reminds me of the Eurovision Song Contest, where there's like the audience voice and then there's the juries.
That's right. Which are very different.
You almost think that's sort of what you are going to end up with, because the jury is sort of some kind of formal. They say this particular thing is right, and then the audience says something else. Luckily, the jury was right this word. Thank you very much. Sweden.
The audience generally says, "Do we like the people from that country or not?" And then vote accordingly.
And they will like different things. But you can imagine things like that, models where you sort of separate out different kinds of credibility functions to work. But then at the end of the day, you have to want to learn what is true as an individual, to learn what is true. That's never going to change.
So it's bringing me back to, we are moving into an environment in all sorts of dimensions where, if traditional interaction was human to human, and then evolved to human using computers, but essentially it was still the human mediated via computer, to an environment, and I'm going to use matrix language this time, Agent Smith. So we're now in a world where it's human to human, but in a world where there are lots of agents. And those agents can be working in all sorts of different dimensions. They're going to be agents in politics, machine-based agents that I think do feel quite different from, the classic bot farm was a human sitting there creating 1,000 personalities on a social media platform. Well, that was still deceptive, but it was I think different, somehow qualitatively different from creating an agent which goes off and sort of does its own thing. And there's this sort of world we now live in, a world sort of populated by these agents. And then from a regulatory question, figuring out who those agents are responsible to, or who has co-responsibility for those agents. If those agents are doing things we don't like, how can we punish that, or control it, or manage it, whatever?
How do they identify as agents is one very basic thing. It seems clear that an agent should represent itself as an agent.
Except
when
the
it
bad
interacts
ones
with
won't. The ones with ill intent won't. So
and then that's something that we should actively think about how we could regulate. And so there's a lot, and I think that sort of the large language models, which are the sort of focus of a lot of the regulatory discussion today, and it's important to remember that AI is so much more, right?
Yeah.
Think about AI for science, where you can do things like fusion or protein folding, so much more. But those language models are not quite agents yet, because you're prompting them, you're putting things in, you're getting things back. But agents is not that far away, and I think it's good for us to have a discussion now about how we feel about the delegation to agents across different possible use cases.
Yeah, and as regulators, how do we extend existing notions of regulation to a world where those agents exist? If we still have the same intention. So, for example, stopping the distribution of illegal content, which society is deemed to be so harmful that we're willing to prosecute a person if they do it. How do we now extend that to a world in which it's agents doing the illegal activity?
And then tracing responsibility and accountability in different ways. And I think that there is a lot of will on the behalf of sort of researchers to figure out how this could work in a way that's safe.
So who's figuring this out? Who's most advanced? The EU's got an AI Act. Is that thinking in these terms? Where's that going?
Well, it's interesting. The EU AI Act started out as a fairly principled piece of legislation where you looked at sort of different kinds of risk categories. And then it suffered that unfortunate fate that legislation sometimes suffers of becoming very popular. So it had some more than 3,000 amendments. And people were sort of just figuring out new things to put in.
The Christmas tree effect. I want to hang my shiny bauble on this legislation.
And you know, it was also in Christmas season, because then ChatGPT came and all of these different technologies exploded, and that coincided with the legislation going into a set of negotiations. So the legislation happened at the very nexus of the technological evolution, and they happened together, and everyone was trying to scramble to figure out how to include all of these different things into the legislation. And I think that is probably not always a good thing for a legislation when that happens, because there's so much that we need a little bit of distance and sort of time to understand, so that if we just throw it in, like generative AI is a term that everyone uses now, or foundation models, or if we throw new concepts in, these concepts might not yet have gelled enough for us to figure out how they apply in a regulatory space. So I think it'll be interesting to see how the trilogues unfold and where sort of the conceptual structure ends up. Then a lot will depend on the implementation agencies, and a lot will depend on the standards that need to be implemented on top of the AI Act. So I think that will be a really interesting.
So EU are playing their usual game of three-dimensional chess. I always think of it as like in the Star Wars series where they have the three-dimensional chess that they're playing on the Millennium Falcon, and you've got the Commission and the Council and the Parliament all.
And since you're talking about Star Wars, I think there's another thing that applies, and I will not explain this, but I will just note that at some point in Star Wars, somebody says, sometimes you have to let the Wookiee win.
Right.
Sorry.
So they're doing that. And then in the US, I notice everyone's queuing up to kind of go, and we need regulation right now. So, of course, the United States Congress is going to have a bill next year, isn't it?
The baseline expectation for the US Congress is that 3 to 6% of the bills introduced on the floor are actually turned into legislation.
Right.
So the question is, will there be legislation before the election? And, I'm not a betting man, but I would say I think that the more likely evolution is that you'll see the administration put forward a series of proposals that can go as industry standards through NIST, for example, the National Institute for, Standards and Technology, I want to say. They have something called a risk management framework that is really well done. It's quite robust. And I think the application of that will be a core part of how the US approaches this. There's also going to be a lot of work, I think, within the White House on figuring out what voluntary commitments could look like. There was a White House meeting a bit earlier where that was a discussion, and I think we'll hear more on that in the coming weeks.
So So more like the EU code of conduct, code of practice type model,
More-
where
more
you get
that
everybody
model,
to sign
yes.
up to agree to certain things.
Yes, more that, I think. And,
Yeah.
and to some degree, I think this is helpful because it sort of gives us several different models. And then you have Canada that is taking a framework law and then relies on local, or not local, relies on implementation of that framework law, which will be a bit more flexible than the European AI Act. And you also see, interestingly, some tendencies in the European Union to worry a little bit about the lead times. Because the EU AI Act comes into force 25-26.
Which is why the Italians are running ahead and banning things altogether. Aren't they?
Well, I think that it's why we hear talk about an AI pact from the European Union now as well.
Right.
Sort of the idea of a code of conduct that could be balanced with and actually interact with the US one. So you could get a very good outcome, which could be a transatlantic framework.
Yeah.
But people will tell me I'm an optimist if I say that's what I think.
Always good to be an optimist.
So we'll see.
Yeah.
And the Italian example is interesting too because it raises a lot of questions that we should return to in a later episode about data protection and AI and how to think about that generally in terms of what you can and cannot do. And there's a series of questions there that the Italian DPA felt they needed answers to, and so they banned ChatGPT, much to the chagrin of their entrepreneurs, and there was sort of open letters and stuff. And then when ChatGPT or when OpenAI, the company behind, had made a couple of changes, they reintroduced it or let it come back into the market. And there's a question about data protection and about a lot of other legislative frameworks here that actually has to do with the fact that we did not have this technology when we shaped this legislation. And what is now proving to be true, no matter what you think about the actual realities, is that this legislation was not technology neutral.
Yes.
It was lauded as technology neutral at the time, but it certainly wasn't. Because the way this technology is designed and the way it works is not predicted within the legislative frameworks. Nobody when the GDPR was put in place, people didn't go, and this will deal really well with large language models. Nobody knew. And it shows the limits of technology neutrality in a time when there is fast-paced technological development.
Yeah, I think there's one bit of that I remember. I think it sort of is in some ways relevant. Is we did ask occasionally if a machine reads something and a human never sees it, what does that mean from a privacy data protection point of view? And we actually think about it in terms of routers, internet routers, that by definition have to see IP addresses and can't ask for your consent. And so is it violating privacy that the stuff goes through that consent? And I think a lot of those questions are the ones that roll over here. If again, a little bit anthropomorphizing.
Yeah.
If an AI is merely a machine and it processes some data, do we consider that no privacy violation has occurred and there's no need to ask for consent and things? Or if we've anthropomorphized it, we now say, but the AI read the data, it must go back and ask consent from the originator of the data. Yes. It is one of those.
The intentionality question becomes quite acute.
Yeah.
If you believe that data protection applies at the moment of intentionality, which I think is also questionable.
Yeah.
A lot of people will say it's processing. That's the term, which means that the routers are for sure processing, and you have to find an exception in the catalog of exceptions to allow the routers to do what they do.
Exactly, yeah. And we have all these notions of natural person. I wonder if we'll introduce in the EU law, introduce an unnatural person. Maybe that's
an artificial person.
Artificial person.
An unnatural person sounds slightly...
So you're right. So I think there are a bunch of areas that we're going to come back to. So there's the data protection questions that are big. There's the copyright and intellectual property questions, which are huge and are rearing their heads again. The law, I don't think... when it was designed, it was all about people copying and stealing and reinterpreting and taking content, and not about machines doing it and the remove. And then the third area is the one I've touched on a bit today about the safety aspect, the illegal speech. In all of those instances, we've made an assumption that it's humans violating privacy, it's humans violating people's intellectual property rights, it's humans distributing illegal speech. And we've created laws that are very much targeted at regulating the humans that might do that and the platforms that permit them to do it. Yes. In all of them, I think there are novel questions for when you have agents who could be violating privacy, violating intellectual property rights and distributing illegal speech, but are not human.
And then there's a huge catalog of AI relevant things that we should talk about, like what does bias mean and where does bias occur in a system?
Yeah.
We should think about jobs displacement. And what do we think about labor market effects? Should regulation be applied to govern those effects? There are questions around autonomous weapons. How do we think about these in international relations and international treaties? There are questions about the autonomy of individuals. If you assume that this agent really gives you good advice, and it gives you such good advice that you keep following it, because when you do, you're happy.
Yeah.
At this point, what happens with your autonomy? And is there a problem here if you learn to be more like the predicted model of yourself that the agent has? So you become more and more of that predicted model, because being that predicted model feels good. You still have free will, but as the Polish science fiction writer Stanisław Lem pointed out, is what you'll be left with is the free will to make slightly worse choices.
Yes, so you're no longer training the agent is training you.
And how do you know? Yeah. How do you know? And these are questions that are really interesting and actually no longer theoretical or science fiction-y. So we have to start these dialogues, talk about these things, and figure it out. I'm quite sure we can, because the upside here is, let's be clear, the upside here is curing disease. The upside is finding ways of doing fusion that will reduce energy costs to zero. The upside is advancing science by hundreds of millions of years in a few human years now. Yeah. So figuring out how this works is going to be really important, because this is a technology that I think we if we play it right, can be enormously impactful. So
I'm just thinking, it's just as well that we've figured out the regulation of social media now, with all of the bills, the Digital Services Act, Online Service, to give us plenty of time to talk about all this new stuff.
To sort out this
new stuff.
We're looking forward to that.
Yeah.
Well, thank you very much. You can find this podcast on your website,
which is www.regulate.tech.
Excellent. And we hope to have you with us for our next session.